Now we're getting into some really important territory. First question, how do you handle data privacy and anonymization in ML datasets? Like masking actors in a movie while keeping the story interesting and meaningful. Privacy techniques include data masking, hide sensitive identifiers, differential privacy, add controlled noise, k-anonymity, group similar records, synthetic data, generate fake but realistic data, federated learning, train without sharing raw data, encryption, protect data in transit and storage. The tips section states, privacy first equals trust always. Second question, design a system for managing training data sampling and balancing, like creating a balanced diet plan where you get the right portions of each food group. System components are data profiling, understand class distributions, sampling strategies, random, stratified, or weighted, balance monitoring, track data skewness, augmentation pipeline, generate synthetic samples, quality validation, ensure balanced quality, version control, track sampling decisions. The tip reminds us, balanced data equals better models. Let's talk about the business side of machine learning. First question, how do you measure ROI and business impact of ML initiatives? Like measuring the success of a new restaurant by counting happy customers and increased profits. The measurement framework includes business metrics, revenue, cost savings, efficiency gains. Baseline comparison, before versus after ML implementation. A/B testing, compare ML versus traditional methods. Time to value, how quickly benefits appear. User adoption, how much the solution is used. Long-term impact, sustained benefits over time. The tips section states, measure impact equals prove value. Second question, explain how to prioritize ML projects in a resource-constrained environment. Like a chef with limited ingredients deciding which dishes will make the most customers happy. The prioritization matrix includes business impact, potential revenue/cost savings. Technical feasibility, how realistic is success. Resource requirements, time, people, infrastructure. Risk assessment, what could go wrong. Strategic alignment, fits company goals. Quick wins, high impact, low effort projects first. The tip reminds us, prioritize smart equals maximum impact. Communication is absolutely crucial in tech. First question, how do you communicate technical ML concepts to business stakeholders? Like explaining rocket science to your grandmother using simple stories and everyday examples. Communication strategies include use analogies, compare to familiar concepts. Focus on benefits. What's in it for them? Visual aids, charts, diagrams, demos. Avoid jargon, plain English explanations. Tell stories, use case studies and examples. Interactive demos show, don't just tell. The tip section says, simple words equals clear understanding. Second question, design a strategy for scaling ML capabilities across an organization. Like teaching cooking skills throughout a large hotel chain so every kitchen can make great food. The scaling strategy includes Center of Excellence, core ML team provides guidance. Training programs, upskill existing employees. Standard platforms, common tools and processes. Best practice sharing, learn from successes. Gradual rollout, start small, expand gradually. Success metrics, track adoption and impact. The tip reminds us, scale gradually equals sustainable growth. Let's dive into some practical business decisions. First question, how do you handle vendor selection and build versus buy decisions for ML tools? Like deciding whether to cook at home or order takeout. Consider cost, time, quality, and control. The decision framework includes cost analysis, total ownership cost over time. Time to market, how quickly you need results. Customization needs, how unique are requirements. Internal expertise, do you have the skills? Vendor stability, will they be around long term? Integration effort, how well does it fit existing systems? The tip section states, evaluate holistically equals better decisions. Second question, explain your approach to managing technical debt in ML systems. Like house maintenance, Ignore small problems and they become expensive disasters. Debt management includes regular audits, periodically review code quality, refactoring sprints, dedicated time for cleanup, documentation, keep everything well documented, testing coverage, comprehensive test suites, monitoring, track system health metrics, prioritization, fix critical issues first. The tip reminds us, regular